This is Lesson 29, the next to last lesson in our march through conquering basic mathematics. In this lesson, we'll discuss solving simple equations, simple algebraic equations. Before we can solve the equations, we need to know what an equation is. An equation must have two things. As shown in the first graphic, an equation must have a variable and it must have an equal sign. In the equation we see 5x plus 3 equals 7. The variable is the x. That is a letter standing for an unknown number. And of course the equal sign separates the 5x plus 3 from the 7. Now, an equation is a lot like a sentence. To have a sentence we have to have a subject and what's called in the grammatical classes a predicate, a verb. And an equation has that equal sign, which is like a verb. So what is something that's not an equation? Well, an expression would be not an equation. An expression would not have an equal sign. For example, 5x plus 3. That's an expression. Is 5x plus 3 true? What does that mean? Or is it false? Well, it means if I stick a number in for x, will it make 5x plus 3 true? The answer is, I don't know. Because there's no verb, there's no equal sign. There's not an equation. This is an expression. An expression is neither true nor false. I could put any number I want in for x. I could put 2 in. 5 times 2 plus 3 is 13. I could put 0 in. 5 times 0 plus 3 is 3. But it's neither true nor false. In an equation, I can put a value in for the variable, and it could be true or false. And our job in solving equations is to find the value or values of the variable that make the equation true. Those are the solutions. So go ahead and let's look at our first equation. X plus 3 equals 8 certainly is an equation. In fact, it's a very simple equation. It's an equation we could have solved back in lesson 1 because it asks what number added to 3 would give us 8. And certainly the answer would be 5. But we want to solve this algebraically, but by solving simple equations algebraically, we can then understand how to solve more complex equations that way. Our job in solving an equation, we said, is to find the true value for x. That is, the value of the variable that makes the equation true. What we're trying to do is isolate the variable. In this particular case, we have x plus 3. In order to isolate the variable, we need to remove the 3. We cannot do that by erasing it. That's not mathematical. The only way to remove that plus 3 is to subtract 3. But in an equation, both sides are equal. And in order to do something to an equation and keep it an equation, what we do to the left side of equals, we must do to the right side of equals. So if we subtract 3 from x plus 3, we also must subtract 3 from 8. And of course, our answer, x equals 5. Anytime we have a solution, we always go back to the original equation. I'll repeat that. We go back to the original equation and check by substituting the solution for the variable. That is, 5 plus 3 equals 8. Of course it does. X equals 5 is the correct answer. Okay. Here are some other examples of how we can solve simple equations. The first equation, x minus 5 equals 8. Well, we want to remove the negative 5, or the subtract 5. And how do we do that? Well, we'll add 5 to it. If we add 5 to the x minus 5, we have to add 5 to the 8, and we get x equals 13. If we check that, 13 minus 5 certainly equals 8. The second equation, 3x equals 18. Well, we need to get rid of the 3. But that 3 is multiplying the x. The opposite of multiplication is division. So we divide the 3x by 3. But if we divide the 3x by 3, we must also divide the other side of the equation, the 18, by 3. And we get x equals 6. And we check that. 3 times 6 equals 18. Yes, it does. Notice still that these equations could have been solved a long time ago without any algebra. They're simple arithmetic facts. But by looking at how we solve them algebraically, we are preparing ourselves for more complex equations that will come shortly. The last of the three equations on this graphic is x divided by 7, or x over 7 equals 2. We want to get rid of the 7. Since we're dividing by 7, we do the opposite. We multiply. If we multiply the left side by 7, we must also multiply the right side by 7. And therefore, we get 2 times 7, which is 14. Checking, 14 divided by 7 equals 2. Yes, it does. The next equation takes 2 steps to solve. We have 2x plus 3 equals 1. Notice that the first thing we do is to isolate the variable term. That is to get the 2x by itself. We do this by subtracting 3. And once again, since we subtracted 3 from the left side, we must also subtract it from the right side. The left side becomes 2x, and the right side, 1 minus 3, is negative 2. Again, our knowledge of subtracting integers is quite important here. Well, now that we have the variable term 2x isolated, we want to make it into x. We need to remove the 2. We do that by dividing, since 2 times x is what 2x means. We do the opposite of multiplication, divide. We divide the left side by 2, we divide the right side by 2, and we get an answer of x equals negative 1. On the right side of the graphic, you can see where we've checked to show that negative 1 indeed is the answer that makes this equation true. 2 times negative 1 plus 3 equals 1. And of course, negative 2 plus 3 equals 1. 1 equals 1. Negative 1 is the only number that will solve this equation. It is the only number that if we use it to replace the x, we will get something that is true. That is, we'll get that 1 equals 1. Any other number, fraction, decimal, large or small, positive, negative, or 0, other than negative 1, if we substitute that number for x, we will get something that is not true. The number on the left and the number on the right will not be equal. We might get something like 7 equals 1, or negative 5 equals 1. The only way to get 1 equals 1 is when x is negative 1. Next, we look at a bit more complex equation. Now we have letter and number terms on both sides of equals. We have 5x plus 8 equals 3x minus 10. We know from our previous method that if we have the x term with a number added to it or subtracted, we then can isolate that x term. But now we have x terms on both sides of the equation. What we need to do is get the x term to be only on one side of the equation. So we either need to remove the 5x or to remove the 3x. Since they're both positive x's, 5x and 3x, we're going to subtract. If we subtract 5x on both sides, we will get a negative x term on the other side. That's not a major problem, but I particularly like to avoid negatives wherever possible. So we'll simply subtract the 3x from both sides. Once we do that, of course, we'll have the x term on the left side. But now on the left side, we also have the plus 8. We need to remove the plus 8. So what do? We subtract 8, and of course subtract it from both sides. So we actually have done 2 steps at once here. We could have done them step by step, but I propose to show you how to do them in one line with 2 separate steps. We subtracted 3x from both terms, and notice we added or subtracted the 3x to the x terms, because x is a place value. And we'll discuss more of this in lesson 30, but x is a place value. And when I'm adding or subtracting, I can only add or subtract x's and x's and numbers, because the place value has to line up. So 5x minus 3x, that is 5x's, take away 3x's, gives me 2x. And 8 minus 8, of course, is 0. And on the right side, 3x minus 3x is 0. And minus 10 minus 8. Well, let's see. Subtracting 8. Well, if the minus sign means subtract, then the 8 must be positive. Subtracting a positive 8 is the same as adding a negative 8. Negative 10 plus a negative 8 is negative 18. So our equation now is simplified to 2x equals negative 18. We have to divide by 2. Since we multiplied the x by 2, we divide by 2 on both sides, and we get x equals negative 9. Checking in the original equation, again, we don't check in some part of the way step. We check in the original equation. 5 times negative 9 plus 8 must equal 3 times negative 9 minus 10. Negative 45 plus 8 is negative 37. Negative 27 minus 10 is negative 37. Negative 37 obviously is equal to negative 37. So we have found in negative 9 the one number that when replacing x in this equation makes the equation true. All other values of x will make the equation false. The left side and right side will not be equal. Okay, let's take a look at another equation. This one a bit more complex. This equation has 2x terms on one side and 2 numerical terms on the other side, a total of 6 terms in the equation. 5x plus 3 minus x equals 7 plus x minus 1. In each case, as we've gone to the next equation, we've added one more step. Here we've added the step of having additional terms. The object is always to get whatever level we're at back to the simpler level that came before it. So obviously what we'd like to do is to get one x term and one number term on each side. Once we get to there, we know what we're doing. It's what we just did in the last equation. Well, that's simple enough to do because you see, even though the 5x and the minus x are not next to each other, since they are the same place value, we can add or subtract the x's. And therefore 5x minus x leaves 4x, because the minus x really is minus 1x. In algebra, when we have no number in front of the variable, like nothing in front of the x, that means a 1x. And if there's just a negative or a minus in front of the x, that means a negative 1x. So 5x minus x is 4x, and of course plus 3. The 3 does not change. On the right side, we can do 7 minus 1 because they're both in the ones place. And 7 minus 1 is 6. So we're left with 4x plus 3 equals 6 plus x. Now we know what to do. What we need to do, of course, is to get the x on one side and the number on the other side. Well, obviously, it would be just as well to get the x on the left side because we'd simply be subtracting x from both sides. And 4x minus x is 3x. And since we have the x on the left side, we need to get the number isolated on the right side. So we need to remove the plus 3 that's on the left side by subtracting 3 from both sides. And we get our equation 3x equals 3. Once we have an equation that has a number times the x equals a number, we divide both sides by the number in front of the x. In fact, there's a name for the number in front of a variable such as x. That number is called the coefficient. And therefore we divide both sides by the coefficient 3. And we get x equals 1. We check x equals 1 by substituting it in the original equation. 5 times 1 plus 3 minus 1 equals 7 plus 1 minus 1. Both sides work out to be 7. So we've checked. This is the correct answer. And in fact, x equals 1 is the only value of x that will, when substituted for x in the original equation, give us an equation that is true. 7 equals 7, of course, is true. The next equation we'll look at is one step more complex. Here we have parentheses, something we haven't seen so far in our equations. Now, we talked about order of operations. We said parentheses say, do me first. But unfortunately, in algebra, for example, 3x minus 7, I cannot do that. I cannot subtract 7 from 3x. The reason being that 3x has x as a place value. The 7 is in the ones place. I cannot add or subtract numbers that are in different place values. The fact that one is a variable and the other one is a ones place, those are different place values. I cannot simplify that expression. So what am I going to do with that parentheses? What I'm going to do is multiply everything in that parentheses by the 2. Because remember, when I multiply a number by 2, I multiply every part of that number by 2. So if I was multiplying, for example, 2 times 34, I'd multiply the 4 by 2. I'd multiply the 3 in the tens place by 2 and get 68. So here I've multiplied the 2 times 3x and gotten 6x, and the 2 times a minus 7 and gotten minus 14. On the right side, I need to multiply the 4 minus x by the negative 2. You say, wait a second, I thought that minus meant subtract. Well, in algebra, it doesn't make a difference. Because remember, adding a negative 2 is the same as subtracting a positive 2. So let's just consider that negative to be a negative sign. And then we multiply negative 2 times 4, we get negative 8. And negative 2 times negative x, well, a negative times a negative is positive. And of course, 2 times x is 2x. So the right side of our equation is 10 minus 8 plus 2x. And now we have an equation similar to the last one we looked at. An equation with more than just 2 terms on one side. What can we do? We can combine like terms. We have the left side is fine, 6x minus 14. There are no like terms to be combined. But on the right side, we can combine the 10 minus 8. And we wind up with 2 plus 2x. Now we simply subtract 2x from both sides. And since the left side will be where our x will be, we'll add 14 to both sides to remove the minus 14. And we get 4x equals 16. Divide both sides by 4, and we get x equals 4. The solution is 4. Checking in the original equation, 2 times 12 minus 7. We've replaced the x with 4, and of course the 3x becomes 3 times 4, or 12, equals 10 minus 2 times 4 minus 4. Well, 12 minus 7, now we can do the parentheses first. 12 minus 7 is 5. 2 times 5 is 10. On the right side, 4 minus 4 is 0. 2 times 0 is 0. And 10 minus 0 is 10. So we have 10 equals 10. And therefore we've checked. The correct answer is x equals 4. Again, the only number that replaces the x in our equation will give us an equation that is true. 10 equals 10. Okay, what I'd like to do now is stop doing just general equations, and we'll come back to a couple for you to do later on. What I'd like to do now is to take a look at an equation that I referred to in a previous lesson. The previous lesson, we discussed problem-solving techniques. I believe that was lesson 28. I mentioned that the problem with the cows and the chickens and the legs could be solved using algebra. And let me demonstrate now how to do that. Again, I would not expect a student prior to Algebra 1 to know how to do this. But I think I want to show you the power of algebraic solutions. Remember, it took us a while using the chart, and had we not used the chart, it could have taken us even longer if we were guessing. What we're going to do is set up an equation, and that equation is going to have one variable in it. That variable will stand for the number of cows. So I'm going to write down x equals the number of cows. Now, the other unknown quantity in our problem was the number of chickens. But there was something we knew about the cows and the chickens. Altogether, they equaled 100. So if we had 80 cows, we'd have 20 chickens. If we had 60 cows, we'd have 40 chickens. If we had 12 cows, we'd have 88 chickens. The number of chickens can be determined by the number of cows. In fact, together they equal 100, which means to find the number of chickens, if you know the number of cows, you subtract the number of cows from 100. And therefore, 100 minus x equals the number of chickens. Now we can write our equation. The one fact we have remaining is the total number of legs was 372. Okay? So let's see. If we have x cows, how many cow legs do we have? Well, since each cow has 4 legs, we have 4x cow legs. Since each chicken has 2 legs, the 100 minus x chickens have a total of 2 times 100 minus x legs. And of course, we're going to add the chicken legs and the cow legs to get the total number of legs. So plus 2, and since we're multiplying by something that has 2 parts, 100 minus x, we use our parentheses. And that is the total number of legs, and that's going to be equal to 372. When we solve this equation for x, we'll have the total number of cows. When we solve the 100 minus x, we'll have the number of chickens. What's the first thing I'm going to do here? Well, I have parentheses. And anytime I have parentheses in an equation, I need to multiply the parentheses by the number outside, in this case by the 2. So the 4x is fine. And then 2 times 100 is plus 200. And a positive 2 times a negative x is minus 2x equals 372. And now I'm left with an equation that has two x terms on the left side. I can combine those like terms. 4x and a negative 2x, or 4x minus 2x, depending how you look at it, is 2x. So I have 2x plus 200 equals 372. Step by step through the problem. Well, now I have an x on one side, but I have numbers on both sides. So I need to isolate the x term. And I'll do that by subtracting 200 from both sides. And I get 2x equals 172. All I have left to do now is to divide both sides by 2. And I'm sure you'll not be surprised to find that 172 divided by 2 is 86, the exact number we obtained in lesson 28 when we did that problem on the cows and the chickens. Obviously, this is a very simple problem, but algebra is such a powerful tool that we can use algebraic equations to solve very complex problems. And in fact, that's in many cases the problems are so complex that we have to program computers to do that. Before we can do it on a computer, we have to understand how to solve simple equations, and of course that's the basic purpose of this lesson. So, let's take a look at a couple of problems for you to do. The first problem shouldn't be that difficult. 5x minus 7 equals 3x plus 11. What I'd like you to do is to stop the tape after you've written the equation down and solve the equation, showing your steps step by step, so that as I go over, you can match up your steps with mine. When you've completed the solution and you've checked your answer in the original equation, turn the tape back on and I'll walk through the solution myself. Okay, well, there are no parentheses in this equation. There are no terms that can be combined. What we need to do is isolate the x term on one side and the number term on the other. So I'll subtract 3x from both sides to get the x term on the left. I will also add 7 to both sides so I can get rid of the minus 7 that's on the left and bring the number over to the right side. When I've completed this, I will have 2x equals 11 plus 7 is 18. Now I have the simple equation 2 times x equals 18. I simply divide both sides by 2 and I get x equals 9. And now I must check. 5 times 9, 5x, is 45. 45 minus 7. That's the left side of the equation when x is 9. The right side of the equation, 3 times 9 is 27, plus 11. Are those two equal? Well, let's subtract and find out. 45 minus 7 is 38. 27 plus 11 is 38. 38 equals 38, which means x equals 9 is the solution for this problem. Now, let's go ahead and go to a final problem that hopefully will challenge you a bit, but that you'll be able to do. Okay, I'm going to erase this and go to our last problem, our last equation to solve in this lesson. Okay. In this equation, 3 parentheses 2 minus 2x plus 13 equals 4 minus 3 times 1 minus x. Okay? Make sure I've copied it correctly. 3 times 2 minus 2x plus 13 equals 4 minus 3 times 1 minus x. Okay? What you need to do is write the equation down if you haven't already done that. Solve it step by step, showing all your work. Check your answer. And when you completed the solution and the check, turn the tape back on and I'll walk through my solution to this equation. Okay, the first step in a problem such as this is to get rid of the parentheses. And we do that by multiplying the number outside the parentheses by all the terms inside the parentheses. 3 times 2 is 6. 3 times negative 2x is negative 6x plus 13. On the right side, the 4 is fine. We multiply the 1 minus x by the negative 3. Negative 3 times 1 is negative 3. Negative 3 times negative x is plus 3x. Let me say now, in my algebra classes, typically one of the errors that students make in this kind of equation is not multiplying the negative times the negative. They wind up with a negative 3x here and, of course, get the incorrect answer. And if they don't check, they don't even know that they have the incorrect answer. It's very important to watch your signs and use the rules that we learned, we talked about, we learned about integers, multiplication, division of integers. Okay, on the left side we have two terms that can be combined. The 6 and the 13 can be added to form 19 and minus 6x. On the right side we have a 4 and a minus 3. 4 minus 3 is 1 plus 3x. Now, here's a case where the x on the left side has a negative coefficient. We'd like to get a positive coefficient, which means we're going to bring the x to the right side. So we'll do the opposite of subtracting 6x. We'll add 6x to both sides. And of course, the left side will look like, well, before we do that, let's also go ahead and get the number on the left side. That 1 has to be subtracted. And if we subtract on the right side, we must also do it on the left side. What are we left with? The left side, of course, is 18. The x's cancel. The right side is 9x. The 1 and negative 1 cancel. 9x equals 18. X equals 2. Okay? Is that the correct answer? Let's find out. We'll substitute in the original equation. 3 times 2. Now let's see. If x equals 2, then 2x is 4. So that's 2 minus 4 plus 13 equals 4 minus, and of course 3 times, let's see, 1 minus 2 is negative 1, right? So a negative 3 times a negative 1 is a positive 3. So the right side equals 7. Does the left side equal 7? Well, let's see. Parentheses on the left side, 2 minus 4 is negative 2. 3 times negative 2 is negative 6. Negative 6 plus 13 equals 7. We have 7 equals 7. X equals 2 is the correct, in fact, the only correct solution to our somewhat complex original equation. So we've looked at a number of equations, some fairly simple and some a bit complex. And again, the purpose of this lesson was not to make you an equation expert. The purpose of this lesson was to show you a couple things. A bit of introduction to the solution of equations so that when you get to algebra and someone says, oh, it's so difficult solving equations, it really isn't. Like everything else, if you're confident that you can do it, you'll be able to do it. But also you can see the mathematics we had to use. We used addition, subtraction, multiplication, division. We had to know about parentheses and the order of operations and working with signed numbers, integers. And of course, if we want to make things more complex, some of those numbers could have been fractions or decimals. But we didn't do that. We'll save that for Algebra 1. Okay, the last lesson, which is coming up, is going to be an introduction to Algebra 1. In reality, we've already looked at some aspects of Algebra 1, but in this lesson, we'll talk about what Algebra 1 is all about. We'll see you, Lesson 30, the last lesson in basic math.